Hi, I'm Dianna Cohen, and I'd like to welcome you to the Plastic Pollution Coalition Global Webinar Series, where we bring together our global community to share the latest information and tips and resources to help stop the growing plastic pollution crisis. Plastic Pollution Coalition is a growing global alliance of more than 1,200 organizations, businesses, and leaders in 75 countries, working to educate, connect, and advocate for a world free of plastic pollution. Today's webinar topic is, will humanity survive plastic pollution? Toxic impact of plastics, chemicals on fertility. Here are a few tips before we get started. We invite you to participate in our poll questions. We are going to turn off the chat now, so please share your questions in the Q&A. And if you would like to share on social, please tag us and our presenters. So to get started, we have 4 poll questions to help us get to know you and your interests. You'll have 20 seconds to respond, and then we'll share the results. Tell us more about yourself. It looks like the majority of people who are filling out the poll are concerned citizens. We have quite a few representatives from organizations and NGOs, but also businesses and researchers, academics, and scientists, as well as students and teachers. Let's go to the next poll question. Where are you joining us from? Please let us know. It looks like the majority of our audience is from North America, but it looks like we have quite a few people tuning in from Europe, as well as Asia and Southeast Asia, Australia, New Zealand, and Pacific Islands, and the Caribbean, as well as Central America. Oh, and Africa. Let's go to the next poll question, number 3. Do you know what endocrine disrupting chemicals are? It looks like the majority of people on the call know something about endocrine disruptors. Some know quite a lot, some very little, and a few of you not at all. So it's going to be a great opportunity for us all to learn. Let's go to poll question number 4. Has anyone in your family or close circle of friends experienced infertility? It looks like the majority of people on the call have had a family member or close friend experience infertility. Today, I'll be in conversation with Shanna Swan, PhD, leading environmental and reproductive epidemiologist and author of the new book, which came out yesterday, Countdown: How Our Modern World is Threatening Sperm Counts, Altering Male and Female Reproductive Development, and Imperiling the Future of the Human Race. It's published by Scribner. I am very excited because I got my copy yesterday. And we'll also be joined by Dr. Pete Meyers, founder and chief scientist of environmental health sciences. Shauna and Pete will discuss how plastics and endocrine disrupting chemicals are contributing to decreasing sperm counts and other negative effects on human sexuality and fertility in both women and men. Both panelists will have 10 minutes to present, and then we will have a moderated Q&A discussion. Throughout the webinar, please feel free to share your questions in the Q&A section and to vote on questions from other attendees that you'd like to see answered, and we'll do our best to answer those. Now I'd like to introduce Shanna Swan, and it is my great pleasure to introduce her. Shanna Swan, PhD, is an award-winning scientist based at Mount Sinai and is one of the leading environmental and reproductive epidemiologists in the world. Dr. Swan has published more than 200 scientific papers and has been featured in extensive media coverage around the world. Her appearances include ABC News, NBC Nightly News, 60 Minutes, CBS News, PBS, BBC, PRI Radio, and NPR, as well as in leading magazines and newspapers, including Newsweek, The Washington Post, USA Today, Time, US News and World Report, The Guardian, Bloomberg News, New York Post, Chicago Tribune, Daily News in New York, Los Angeles Times, HuffPost, Daily Mail London, New Scientist, Mental Floss, Mother Jones, New Telegraph, Euronews, and the National Post. She is the author of the new book, Countdown: How Our Modern World is Threatening Sperm Counts and Altering Male and Female Reproductive Development and Imperiling the Future of the Human Race. I'd like to turn it over to Shauna now.
Thank you, Dianna, so much for that introduction and for the ability, the opportunity to talk to you all, but also thank you for Plastic Pollution Coalition, which is so important and doing such critical work at this time when our reproductive health is so severely threatened. All right, so let's get started. So what I'd like to start with is a study that we published in 2017, August, which actually went pretty viral. You see here a cover of Newsweek, Who's Killing America's Sperm? And this was a study that looked at the question of declining sperm count worldwide for about 40 years. This was the last effort of a 20-year effort that I've made to look at this question, starting from being very skeptical about initial signals that sperm count was declining until this publication, which made me really convinced that we have a serious problem. So what is that problem? Well, what we showed in this paper, which is, by the way, the largest and most rigorous paper of its kind ever written, we showed that between 73 and 2011, which were the years that the sperm were collected in this study, sperm count had dropped 40%. This was very significant statistically, and it was not slowing down. And when I say not slowing down, I mean, if we looked at 20 years instead of 40 or 10 years instead of 40, you might think, well, the slope is leveling off. But we didn't see that. What we saw was that if things went ahead as the data suggested, that by 2045, this curve would hit zero. And what that means is that the median sperm count is zero, okay? You can't have a negative sperm count. So half the men would have zero, and then the other half would be, a lot of them, very close to zero. That means that the majority of men in Western countries would not have enough sperm or have difficulty conceiving a pregnancy. This is very serious. And there are some other lines here. There's a blue line and an orange line, which do not hit zero anytime soon. And those are the curves that we want to shoot for. We want to push this curve in a direction that keeps it away from hitting zero. And we'll talk about some ways to do that. But it's not just sperm count. And I'm here to tell you that reproductive health in men and women has been declining over the past at least 40 years and longer than that, I believe. And let me talk about some of those ways. Low sperm count, a shorter perineum, that's the overall size of the genitals, if you will. I don't have time to go into that in great detail, but also smaller penises, I think that's understandable, a smaller scrotum, reduced testosterone, and genital birth defects in the male. What's interesting about the trends in these endpoints is that they are declining, or the risks are increasing, for example, for birth defects, at about the same rate. They're all about 1% per year. On the female side, we have babies born with low birth weight and prematurity. That's increasing. Menstrual problems, endometriosis, premature egg depletion, early puberty, and miscarriage. All of these, for example, miscarriage has been increasing at 1% per year. And perhaps most significantly for the future of the human race, infertility has been increasing, or the fertility, that is the number of children born to a woman or a couple, has decreased 50% worldwide in the past 50 years. So there's a real problem here, and these things are clearly related because they are proceeding at the same rate. So what could be causing this? So I've separated possible causes into genetic. While genetics undoubtedly plays a role in all this, it's not going to be causing a decline at this rate. This is too fast for a genetic change. So that means that it's an environmental cause, and that can be lifestyle or chemical. And I've worked on both of these. I'm going to talk today about chemical exposures because plastics fall in that category. And those can be endocrine-disrupting chemicals, chemicals that have the ability to alter the reproductive system, it alters the hormones and alter the endocrine system. That's why they're called endocrine disrupting chemicals. And then there are other chemicals, and they also play a role. And under the EDCs, or the endocrine disrupting chemicals, we have phthalates and bisphenols, which are particularly in plastics. We also have PFAS, which is also has plastic in there. Pesticides, by the way, phthalates are in pesticides. Flame retardants, they're all relevant to this discussion. So one of the key players in this story is testosterone. Endocrine disrupting chemicals alter our hormones, in particular our steroid hormones, and in particular our testosterone. And this is very clear and important for the declining reproductive health of humans and other species. So for example, phthalates shown here in nail polish, in a shower curtain, in tubes collecting milk from a cow, are all very significant sources of the kinds of phthalates that can interfere with testosterone. And what does that mean? Well, specifically, let me show you one set of graphs. On the left, we have the surge in testosterone that occurs in early pregnancy in a rat who is not exposed to phthalates. There's a very clear peak in the testosterone, but if we go to the right-hand curve, when the mom is exposed to phthalates, in this case, diethyl hexylphthalate, one of the most anti-androgenic phthalates, you see that that curve is completely wiped out. That means that that mother is not seeing the testosterone surge when she needs it and when the fetus needs it to masculinize. It turns out that when this happens, this male rodent shown here develops in a less male typical way. He will have smaller genitals and undescended testicles. This is very significant. It's been shown in many species. And I asked, what about humans? I conducted a series of studies to look at this question by looking at the phthalate metabolites in the urines of mothers, and then looking in their children at endpoints that represented the phthalate syndrome once we could measure them. And what we found was the phthalate syndrome. We found it first and published in 2005, and this was a very big news and actually influenced, I think, the exclusion of phthalates from children's toys in the Consumer Protection Act. And then we repeated it and published that in 2015. And the fact that we have this replication in humans, we have other studies that have supported this, we have the animal data that have supported this, we now know some of the mechanism that's involved. This is as close as we can get as saying that these phthalates actually cause the phthalate syndrome in human males. And we know now that phthalates are anti-androgenic, they drive down testosterone, that they're endocrine disruptors. And this measure that we used, AntiGentle Distance, is an important marker of the androgen exposure in utero. People ask, why should we care about AntiGentle Distance, that measure from the anus to the genitals? Why is that important? Well, it turns out it's extremely important clinically, because men who have a short AntiGentle Distance have a low sperm count, and men who are infertile have a men who are infertile have a short AntiGentle Distance, and children that have malformations of the genitals, male children, have a short AntiGentle Distance. So it's a very important marker of a clinical endpoint. And I should tell you that the consequences of having these disturbances, which show up at birth, predict disease later in life and earlier death. And there's an analog for females that I don't have time to go into, but this is a phenomenon that is important throughout the life. And we call these disruptions of reproductive health the sixth vital sign. So we clearly have a problem. And that's why you're on this call, and that's why this organization exists. We all recognize this problem, but I just want to point out that only perhaps 250 of 60,000 chemicals have been directly tested for endocrine disruption and for toxicity by the EPA. So that's not going to get us to our goal of turning that curve away from zero, which we must do quickly if we are going to avoid catastrophe by 2045.
Shauna, thank you for that. Just before we proceed, just one quick question. Could you give just a basic definition of what phthalates are? Because I've had some people ask that.
Sure. So phthalates comprise a large class of chemicals. They're best thought about by their uses. So they make plastic soft and flexible. And in that function, we see them in things like rubber duckies and shower curtains and pacifiers and rubber tubing. The best example, I think, is I love to think about the children in the neonatal intensive care nursery who have these lines coming into their body providing nutrition. And we've shown, other people have shown, that the number of lines coming into that infant is directly related to the amount of phthalates that measured in their urine immediately afterwards. So what happens is that these phthalates leave the plastic, they're not chemically bound, and they go into the food, and then they go into us, and they also go into our unborn children. Another important source of phthalates is in cosmetics. So phthalates also make increase absorption. They increase retention of fragrance. They add color. So they're added to lipsticks. They're added to nail polish. They're also added to pesticides because they help retention of the pesticide into the plant. So those are just some uses of our very all-pervasive class of chemicals called phthalates.
Thank you very much. Thank you for that. So now it is my great pleasure to introduce Dr. Pete Meyers. Pete Meyers is the founder and chief scientist of Environmental Health Sciences, a nonprofit organization that promotes public understanding of advances in scientific research on links between the environment and health. And you can learn more about them at environmentalhealthnews.org. Dr. Meyers holds a doctorate in biological sciences from UC Berkeley. While director of the W. Alton Jones Foundation from 1990 to 2002, he co-authored Our Stolen Future, a bestseller that explores how contamination threatens fetal development. Pete has served on numerous nonprofit boards, including as board chair of the National Environmental Trust and board chair of the H. John Hines Center for Science, Economics, and the Environment. And Pete has received multiple major national and international awards, including the Laureate Award for Outstanding Public Service from the Endocrine Society in 2016, the Champion of Environmental Health Research Award in 2016 from the National Institutes of Health, and the Distinguished Service Award in 2017 from the Sierra Club. Pete is also a Plastic Pollution Coalition scientific advisor. Welcome, Pete.
Let me repeat what Shauna said, how great the Plastic Pollution Coalition is in bringing together multiple sectors, lots of people all around the world to solve what is a very serious problem. And second, I want to say what an honor it is to be on this call with Shauna, with whom I work very closely and whose research I respect very deeply. In fact, so deeply that I'm going to begin with her slide. This is the slide taken from the 2017 paper that she talked about. But what I'm going to do is I'm going to focus on 2045. That's the date, okay? And as Shauna said, if you look at if you project median sperm count forward from now to 2045, median sperm count drops to 0. Now, Shauna and I both agree you can't assume this will happen, but you can definitely worry about what happens if it does. And that's why we're here today, because we think the chances, given that this trend has gone on for so long without changing the rate, it's probably going to continue, and it's probably going to approach 0. And so here we are, 2021. 2045 is only 24 years away. We've got a serious problem to solve within a generation of people. In fact, if you look at these kids, these toddlers there in that photograph, half of them will have sperm counts of 0 by when they're measured in 2045. That's shocking. Those are kids who are already born. That's shocking. And the question is, what can we do to move the curve in the direction that Shauna indicated? That's our goal. We've got a problem for the human race, but we have a second problem, which is that people aren't the only things on the planet. And it turns out endocrine disrupting compounds affect other species on the planet in many different ways. And if you know enough ecology, you understand that we need those organisms with us. If we solve the human problem and we don't solve the problem of other life on Earth, it's probably moving along with us towards reduced fertility. It's not going to be good for people. So what's happened is we are now the canaries in the coal mine. We used to use canaries in coal mines to tell miners that they were going to have problems with carbon monoxide and get out when the canaries start to die. Well, when you look at the research that Shauna has done and our colleagues, it's cost millions of dollars, money well spent. But there's no way that we can spend millions of dollars to find out the reproductive status of every species on the planet. We just aren't going to be able to do it. And so what we have to do is we have to take the warnings from people and begin to ask, what should we be doing to protect the rest of life on Earth along with people? A couple of points I want to make. Plastics and plastic chemicals are now abundantly ubiquitous in the environment. They're on the highest mountains. They're in the Arctic snow. They are in the Antarctic deep. They're at the bottom of the Marianas Trench. They're in remote tropical rivers worldwide. And they're on sandy beaches. They are everywhere. Chemicals from plastics and plastics are everywhere. That's not a good thing. How did they get everywhere? Well, we carry them. We take them on planes and then throw them away. We put them in landfills and the landfills leach. And actually, BPA and phthalates are huge components of the water that leaches out of landfills right now, today. And it's causing problems because downstream of where that landfill leaches often is where the next city down the river gets its water. And it means endocrine disrupting compounds from plastics are in that water. Those chemicals volatilize, they evaporate in the heat, and the wind blows and carries them around the world. Rivers and ocean currents carry them also. And then animals migrate. And I could tell you stories about how animal migration has led to changes in the distribution of chemicals, dangerous chemicals, but I don't have time to do that. There is no uncontaminated place on Earth. That's really important to understand. There's no uncontaminated place. You're up in the mountains in the Sierra Nevada, it's contaminated. I'll say a little bit more with this slide. This is actually a slide showing results looking at pesticides that are semi-volatile, which means just like plastic compounds and plastic chemicals, they evaporate in the heat. They get picked up by the wind, they're carried downwind. And in this study, which was done in Costa Rica, adjacent to banana plantations, the pesticides were carried into the mountains downwind, and the concentrations in the cloud forest of Costa Rica were higher than the concentrations in the forests adjacent to the banana plantations. This is a classic result of the semi-volatile nature of these chemicals and interacting with the heat of the sun. It happens everywhere, and they deposit in cold places, particularly mountaintops and the Arctic. So here's some crucial science on endocrine disruption that you have to think about in regard to this problem. First of all, EDCs have severe effects at very low concentrations. They're especially important during fetal life. In fact, a hit during adulthood might have little effect. The same hit to a fetus can destroy its future fertility. And this happens because EDCs hack hormone signaling. They alter how genes are expressed, which is vital to the proper development of the reproductive system and lots of other things that happen in people and animals. So here's a interesting graph. And what I'm showing you here is the bottom line reads parts per trillion, billion, million, thousand. Trillion is 1,000-fold bigger than billion, is 1,000-fold bigger than million, is 1,000-fold bigger than thousand. But parts per trillion is 1/1000th of a part per billion. Okay, so this is a scale of concentrations. And what I'm showing you here is, can you see the my cursor? You see the cursor? Okay, no. So this is the level at which hormones work. 0.1 parts per trillion, up to on the order of 1 to 10 parts per billion. Really low levels. That's the natural range at which hormones work to change gene expression. Toxic compounds, on the other hand, work in the range of parts per million and parts per thousand. That's what toxicologists have studied forever. And they have ignored the ranges of EDC exposures, which are much more similar to where the action takes place, much more similar to hormones than traditional toxic agents. So you can see here that this zone of EDC concentration, similar to the zone of hormone concentration, is where we're running into trouble. So let me just make this kind of real. What's a part per billion right there in the graph? A part per billion. And let me put it this way. Imagine you have a drop of water, and that drop of water has 1 part per billion bisphenol A in it. How many molecules of bisphenol A do you think are going to be in that drop of water? Well, it's 2.65 trillion molecules of BPA are in that drop of water. Okay, it's not a small amount. It might sound like a low concentration, but there are a lot of molecules of bisphenol A to interact with hormone receptors, to interfere with hormone signaling and cause trouble. And this is the whole root of the endocrine disruption challenge. So I'm going to end with one example that's very personal. I remember when I was a kid growing up in Latin America, in Mexico, but also even before that in the US. In the spring and the summer, you drive around and your windshield would be covered with splats, dead bugs. Scientists have now documented that splats on windshields have decreased by 80% over the last 20 years. Something's happening to insects, okay? It's very serious because as much as you might not like mosquitoes, we need insects to live. They are part of an ecosystem function that we cannot replace even with all of Elon Musk's fancy machinery. I want to tell you I want to link this observation to phthalates. There's been some really interesting work done by French scientists around the world sampling phthalates in ant cuticles, the skin of ants. They've sampled ants on 3 continents in, I forget, 30 odd countries, some 200 samples. Every ant had phthalates in its skin, every ant. And they didn't need to collect them in the middle of cities. Instead, they actually did a sample in the Amazon, where you can see a bunch of sampling locations. These yellow pins are near civilization, but one of them was all the way down in this field station in the middle of the Amazon forest, and it had phthalates also. And the phthalates measured in the ant cuticles, when they did experiments, were sufficient to suppress fecundity of the ant queens. So ant fertility is being affected by phthalates at levels found all in every place someone has looked seriously at it. So back to the canary in the coal mine. We can't just look at canaries dying. We've got to get out there and start doing something about it that shifts Shauna's curve of where the sperm count is going and get it away from 0 at 2045. And we also have to respond to the challenge that ubiquitous abundance of chemicals related to plastics throughout the world almost certainly are contributing to loss of fertility in wildlife. Thank you.
Thank you, Pete. Thank you, Shauna. It's heavy, you know, this is really sobering information to absorb. But I want to be complimentary again, though, about Shauna's new book, because I feel like you've done a fantastic job speaking in a way that engages a lay person, a person who doesn't have a scientific background, your average person who wants to try and learn about this issue and to take steps to contribute to the solutions around it. So I'd like to thank you both very much for sharing your knowledge with us. And let's begin our Q&A discussion. Many people pre-submitted questions, but I was thinking one that's been ticked up and voted on in the live Q&A is, are there ways to remove plastic toxins from the human body?
First of all, I just have to say, Dianna, that thank you. And the reason the book is so accessible to people is because I wrote it with Stacy Colino, who is a super science writer. And so I have to give her credit for that voice. Okay, but now as far as removing plastics, let me just say, plastics do not stay in our bodies, which is a good thing. They're not forever chemicals. They have a short half-life. They're water soluble. They're excreted in the urine. Their half-life is 4 hours. So this is really good news, that if we could get them out of our stream of commerce and out of our houses and out of our foods, then we would be rid of them because they're not sticking around. They're not forever chemicals, which we can talk about also. Pete, you want to add to that?
Well, I would say that forever chemicals, the perfluorinated chemicals, are often included in plastics. So they're part of the mix. They technically, they're not plastic chemicals, but you can be exposed to them via being exposed to plastic. I would point people towards an earlier book that also was very accessible, Slow Death by Rubber Duck, written by Bruce Lowry and Rick Smith. And what they did was they locked themselves in an apartment. I think it was Rick Smith's mom's apartment, and they changed their living habits, their lifestyles, very methodically for a week, trying to push up their phthalate and bisphenol A levels, for example, or to reduce them. And they found that most of the chemicals they experimented with responded to the treatment. So not only do they not stay in your bodies forever, you can avoid them. You can reduce your exposure to them if you act with that knowledge. The one family of chemicals that did not change rapidly, like BPA or phthalates, were the perfluorinated, the forever chemicals. And the reason why they didn't change is they're forever chemicals. They're with us.
Yeah, so we have amazing questions from people. I want to just balance how I'm asking them of you, but this is a question for Shauna. Are fertility problems evenly distributed across the globe or across particular ethnic groups? And what is the environmental justice or inequity impact of that?
So that's a really important and hard question. And one of the reasons the answer is no, they're not distributed equally. Okay, we know that. And there's many people working on the inequities in the distribution of these risks. I'd like to say two things, one about the distribution of the compounds themselves and one about the response to the compounds. Okay, so as far as the distribution of the compounds, we know quite a bit about how these compounds are distributed from studies in the United States and some isolated places in Europe. We do not have that information throughout the world. There are many disadvantaged communities around the world for which we do not have any idea what the exposure is, okay? And it's likely higher because when we do have communities, say in my studies, I have 4 centers that I'm looking at right now. One of them is a center in Rochester, New York. And there, the majority of the participants are on Medicare, they're disadvantaged, and they have significantly higher exposure, for example, to phthalates and bisphenol A. And many people have shown this, and Haynes has shown this, National Health Examination and Nutrition Survey out of the CDC. You can look that up and you can see what the distribution is by race and ethnicity. So that's the exposure. Yes, it differs and it's higher in disadvantaged communities. There's no question about that. But the other part of it is that the impact of these chemicals is also different in different communities. And we just published a study showing that, for example, the effect of phthalates on certain neurodevelopmental endpoints is much stronger in our Rochester study. Because if you have a disadvantaged community that has more stress, that has more obesity, that has poor medical care, they're going to be more sensitive to the impacts of these chemicals. So finally, I want to say that we don't have the information we need, because to get this information, you have to bring people into a study. You have to decide to select that community to study. And that's difficult, more difficult in disadvantaged communities. So we are short the information, and but there's no question that the impact is greater in disadvantaged communities.
So, well, to continue along this line, there was a question, which I think might be for you, Pete. Are there any safe plastics? And to complement that, folks were also asking about how can marginalized groups who can only buy plastic, such as drinking from bottled water because it's safer than the contaminated groundwater where they're based, how can they help prevent plastic pollution, and I would say their own exposure?
Yeah, let me take the first question first, and then turn to the second, and maybe with Shauna's help. Are there safe plastics? Well, there should be, but we don't know, because no plastic has been completely tested for safety. And as scientists use more and more assays for what's safe and what's not, they find a higher percentage of the plastics they test in any given sample are not safe. Not all of it's endocrine disruption safety. There are multiple types of this sort of testing that go on. But one of the complications is, which if this were not the case, it'd be easy. The answer would be easy. We all know the recycling number 1, 2, 3, 4, 5, 6, 7, which more or less falls out on different monomers involved in making the plastic. Plastic is a polymer. It's a chain of monomers that are put together. And the 1, 2, 3, 4, 5, 6, 7, for the most part, are indicating what's the monomer. The problem is no plastic is pure. And it's not pure for several reasons. Probably the most important one, this is where phthalates come in. There are additives to plastics that can be toxic. And many of these additives are added to many plastics that might otherwise be relatively safe. That's, for example, true for bio-based plastics. Recent testing, published last year, shows that bio-based plastics are just as likely to be hazardous as petroleum-based plastics, almost certainly because of the additives that are put in to achieve the softness, the hardness, the rigidity, the material characteristics that the chemical engineer wants to have for a product. So it's a challenge. And then lastly, because to make plastic cheap, and plastic is cheap, we all know that, the raw materials used to make plastic, the sources of the monomers, aren't fit for use by NASA or the Silicon Valley guys and gals. Instead, they have imperfections in them, and those imperfections create And they have pollutants in them already, and they create what are called non-intentionally added substances, which add another dimension of toxicity, which unfortunately puts us in a situation that every batch of plastic, to be absolutely certain, every batch of plastic needs to be tested for safety, and they're not.
Right. And Shauna, could you speak to how could we suggest that marginalized groups who may only be able to buy plastic bottled drinking water or products in plastic, what might be safe because it's safer for them than their local groundwater or pipes, et cetera? What could they be doing to help reduce their exposure and to prevent plastic pollution?
That's such a hard question, right? So there's, bottled water is not tested at the same level as tap water in most communities in the United States. So we can't assume that bottled water is actually safer than tap water. Aside from the bottles that it comes in, the water itself is not necessarily safer. There are some home treatments. There's home filtration that can help. And there's also distillation, which you can do at home, which we do. I have a distiller here. I distill my water, even though I'm in New York, which has good water. So I would say that home treatment is probably the best solution, particularly for communities that are in, neighborhoods that have questionable water.
If I could add to that, I think that highlights one of the deep inequities of this issue. A lot of people can't shop their way out of this problem. We need policy changes that protect people. And I have to admit, I was really pleased when I saw the governor of Michigan was arrested for what happened in Flint. Not the governor, was it the governor or was it his chief henchman? But they were starting to pay criminal penalties for how they handled the water situation there.
We're getting asked also what steps an average person could do to hold plastic polluting corporations accountable and, create extended producer responsibility laws. Do either of you have suggestions?
Well, that's why I joined the Plastic Pollution Coalition, to learn from you.
Well, that's something that I was going to talk about at the end, but yeah, I could actually just mention now that, we are part of where we've helped create the Break Free from Plastic movement. And there is an act that is being reintroduced. It's an important piece of federal legislation. It's called the Break Free from Plastic Pollution Act. And it's legislation that advances practical solutions to systemically address the plastic pollution crisis. And that is actually our next webinar in March. We'll be discussing the reintroduction of the Break Free from Plastic Pollution Act. And I'm just going to ask everybody on this who's interested in that, including you, Pete and Shauna, to stay tuned for more details, and we'll have the date soon with information.
Great.
About that.
That's exciting. Great.
Can you discuss the relationship of plastics and increases in childhood neurodegenerative disorders?
There is unquestionably a connection between altered neurodevelopment and prenatal exposure, particularly to plastics, to phthalates, to bisphenol A. We see that in our studies. Other people have seen that. So what the setup is you have pregnant women, you get their urine, you measure these things in the urine, and then you let the children develop and you test them along the way. And our children are now, in our latest study, are now 8 years of age, and we have published many papers, as have many, many people, on changes in behavior. Most of these studies are not large enough to look at rare conditions such as autism, although there are studies now that are looking at that, including one of ours. But there's unquestionably a link between altered neurodevelopment behavior and plasticizer exposure in utero.
Well, okay, I have a big question for you guys. This is from
They haven't visited already.
no, this is from our friend Goffinet. McLaren, and she asked, could the invasion of plastic chemicals in human bodies be considered a crime against humanity?
I'd like to say something about that. I think that people have to realize that by threatening our health and our fertility and our ability to have children, it is a, if you will, a crime against the unborn or the in utero child that's we're experiencing. We have higher pregnancy loss. We have more difficulty conceiving. We have lots and lots of impacts on the ability to have children. Those children who we value, the unborn children that we're losing due to plastic pollution, well, if that isn't a crime, I'm not sure what is.
Yeah, I hear you. I agree. Another important question. Sorry, I realize these are all really big questions, and we could, talk about them in much deeper ways if we had more time. What are the impacts of synthetic petroleum-based fibers and toxic dyes used in producing most of our clothing on human reproductive health?
I don't know. Maybe Pete has an answer.
That's closer to your wheelhouse than mine, Shauna.
Well, I don't know what chemicals we're talking about. That's the problem.
Yeah.
So I can't answer that. Yeah.
It's a broad range. I think maybe the references to synthetics like polyesters and what we're seeing with microfibers.
Yeah. Well, the microfiber story and the microplastic story is really, really important. And it's just breaking now, actually, where people are just starting to recognize this other source of exposure. So the question is, what's the size of the molecule? Whether it's micro or nano or macro. And then we have to ask, does it get through to critical areas? Does it cross the placenta? Does it cross the blood-brain barrier? Does it cross the testes, blood barrier? And so anything, the smaller chemicals are likely to get through to more places, and so to be more risky. But we need to do the science. We haven't done that yet.
Right. I'm just going to keep coming with questions until we run out of time. So we're being asked to please discuss the possible association of endocrine-disrupting chemicals and transgender identity and other gender-related issues, as well as androgen insensitivity syndrome in humans.
I guess that's for me also, although Pete might want to say something about that.
Well, one of your chapters is about that, so I'll let you.
It's a really, really compelling chapter, I'm just going to say, in the book.
Thank you. It's probably the hardest chapter in the book to write. And this is probably the most difficult question, because really we don't know. We don't know, for example, has the incidence of gender dysphoria increased? It appears that it has, but we have no good baseline. So I would say that's unknown. Are plastics and chemicals in plastic and endocrine disrupting chemicals related to the occurrence of gender dysphoria? I would have to say we don't know in humans. Our colleague Tyrone Hayes made a very eloquent case for this occurring in frogs, and I'll just tell you what he said, and I need to get more information, but he said that in his laboratory and in the wild, when he sees frogs exposed to atrazine, the pesticide, this is not about phthalates, but you'll get the idea. Many of these frogs have disorders of sexual development, and they have male and female organs in the same animal. And when he looks at a group of these and identifies them, he sees certain individuals that when they're mating, they're not really mating, but they're having sex. When they're having sex, certain of these individuals, even though they all have this disordered genitals, one of them will always prefer to be on the bottom, another one will always prefer to be on the top. Well, that may be as close as we get to opting for a feminine identity or a masculine identity as you can get with a frog. And that is caused by atrazine. Pete, do you want to say anything more about that?
Well, we do see widespread feminization of fish in rivers that have both pesticide loads and sewage disposal loads, and that those sewage disposals are full of things like atrazine and phthalates because they come out of landfills. It leaches out of landfills. So there are widespread examples of this feminization of male fish, but we don't really know how that relates to the situation in people. As Shauna said, it's really hard to establish a baseline, and it's a very difficult question to answer.
Yeah,
The couples that are going for assisted reproduction have more difficulty when they have higher levels of phthalates and bisphenol A in their urine. So there's an immediate payment. You're paying immediately at the time you go for that ART for the chemicals in your body.
And I would take that as an opportunity to talk about the inequities that will arise as only rich people can afford ART and poor people don't have the luxury of using artificial reproduction. That's going to be a huge inequity as this issue evolves.
So there, by the way, you guys, there are many more questions, but we only have a few minutes left. And so I'd like to just turn to the positive part of your book, Shauna, which was very exciting to me. I think it's not only envisioning a healthy future in chapter 13, but chapter 12, reducing the chemical footprint in your home. And I was wondering if you could just share some overarching recommendations for people, but I hope everyone will also learn from your book and your research.
Sure. Well, thank you. While it's true we cannot shop ourselves out of this crisis, we can certainly decrease our daily exposure. And one thing we can do is not to, buy unprocessed food to the extent that we can, not to eat out of cans unless we know what they're lined with. And in general, don't heat in plastic, don't store in plastic. Try to avoid the use of plastics in your home to the extent possible. Try to use cosmetics and cleaning products and other products that are safer. And a good way to do that is I recommend going to environmental working groups, consumer guides. I think they're excellent, and I do that. There's other things we recommend in the book, but I think being aware is a really important first step, that we're aware of the problem, that we know that it's something we want to reduce, and then we can take action.
If I could add one note to that, which was an excellent summary, don't minimize your handling of ATM receipts. They are coated with bisphenols. It comes off on your fingers. It's absorbed into the skin. It's probably the biggest single source of bisphenol exposure around. So avoid that.
Thank you, Pete. And I'd just like to let everyone know that we'll do our best to capture all of the questions from the panelists and add answers to our blog and help follow up with everybody when we make the recording available from this. So with that said, I want to send big hugs, virtual hugs to you, Shauna, and to you, Pete. And big thank you and hugs to everybody for tuning in today. Again, our next webinar will be in March. We'll be announcing that soon, and the focus will be on the reintroduction of the Break Free from Plastic Pollution Act. And we invite you to get involved with us at Plastic Pollution Coalition. We invite you to connect with us on social media to learn more. We'll be sending out a link to a survey, and we'd love to get your feedback on this webinar. And I want to just send out a big thank you to everyone for joining us today. Thanks very much. Take care, everybody. Stay safe.